Welcome everyone, this is Antonio Cuni, PyPy status update.
Thank you. Good afternoon to everyone. So this is a talk about PyPy status update. I just want to tell you about the latest news in the PyPy world, since a lot of things has changed since the last time I talked here. First, a few words about me. I have been a PyPy core developer since 2006. I have spoken here at PyCon Italy and EuroPython a lot of times, so a lot of you already know me. I am a freelance consultant. I do also a bit of training. I'm also the author of other open source Python module that maybe you know, like PDB++ or Fancy Completer. And what is PyPy? I suppose that a lot of you already knows about it, since you are here to hear the news. But for those who don't, PyPy is an alternative implementation of the Python language, which means that you can use it to run your Python programs instead of using the standard CPython interpreter. The biggest difference between PyPy and CPython is that PyPy has a JIT compiler, just-in-time compiler, which means that usually the programs go faster, or at least this is the goal. The speed is reached using techniques like the JIT compiler, and also by using a more advanced garbage collector than CPython. Recently, last week, we released the version of PyPy 5.7.1, which runs on a lot of platforms. Our focus is on x86, 64-bit in particular. Our primary platform for development is Linux, but PyPy works also on Windows, on Mac, and it works also on other CPUs like ARM, PowerPC, and others. So since I told you that PyPy is meant to be fast, this is a chart that you can see from speed.pypy.org, which is a website where we run nightly the benchmarks against of the latest version of PyPy against CPython. The orange line is the performance of CPython, and you see that on these benchmarks we are always faster, much faster sometimes. On average, we are 7.4 times faster than CPython. Of course, it's not that you can say that PyPy is 7 times faster than CPython. A single number doesn't make any sense. You have to take your program and measure it. Sometimes it goes faster, sometimes it's not as fast, but yes. So basically, these are always the same slides. I copy and paste the very same slides every time I do the talk. So probably if you have already been hearing me in the past, you knew about this stuff. And then I would like to do another kind of talk this time, because usually I spend a lot of time talking about stuff, and then at the end I get a lot of questions. And most of the time the questions are always the same. So people ask me if PyPy is stable and mature enough to be used in production system, like can I use it for a real thing, or is it just like a toy or a research project? The other question that they always ask me is if the package X work or not on PyPy. And finally, usually people also want to know about the future, so what is the status of Python 3 on PyPy. So I'm doing a Q&A at the reverse, and I will answer this question during the talk. So let's start with stability and maturity. Basically, what we saw in the past years is that PyPy is used a lot in the real world. There are a lot of companies which are using PyPy in production for doing stuff which make money, for running a system in which if you have a crash or a logic error, well, it's a big problem because you lose money or customers. So there are companies who are using PyPy for this kind of things, which means that they are happy with it. And I would like to present a couple of examples which I've heard about. The first is Gambit Research, which is a company who does high-frequency trading in the area of sports betting. And they have been using PyPy since 2012. And as you can see from the slide, they really use it for running long-term processes which run 24/7 every day. The cool thing is that for them, having a high speed is really important, because it means if you go faster, you make more money, basically. So at some point they had problems with performance with CPython, and they tried PyPy, and they measured the speed ups up to 10 times faster. But as I said, 10 times as a number doesn't make much sense alone. What happened is that they first tried PyPy, and they didn't see a good speed up at all. But after a few careful optimizations here and there, we managed to arrive at this important speed up. This is a very clear case, because it happens a lot. Maybe you have your program and it's slow, you try PyPy, you don't see any important speed up, and then you just forget about it. But sometimes maybe it's worth trying to understand why it's not going faster, because maybe changing a couple of lines can really bring good speed ups. I know about this stuff because I am the one who did the careful tuning of their system. Of course, for me it was easier because I knew the internals of PyPy, so I knew that this kind of code was meant to be fast. And what I did was to look around in the code, profiling, and see where there were the bottlenecks, and I saw that there were a couple of places in which we did things who disabled the optimization of the JIT. So by removing these things, the JIT could do its full job, and we got the massive speed up. Then there is another company which does something completely different. The company is called Magnetic, and they work in the online advertisement field, and they share with Gambit the requirement of needing a very low latency. And again, they measured a lot of speed up compared to CPython. And I asked the lead developer, and basically he said that they run PyPy everywhere. They just don't use CPython because for them it was not worth of. And again, the third example I want to show you is crossbar.io, which is a system to let IoT devices to talk with each other in the cloud. And I asked the core developer again, and they say that for them PyPy really gave a huge speed ups, again like Gambit, in the order of magnitude of 5 or 10 times faster than CPython. And again, it told me that they don't even try to run CPython anymore, because for them PyPy is much faster, and it doesn't make sense to optimize for CPython. So all of this is just a quick overview to convince you that PyPy is stable, and so if you have performance problem, probably you should look at it. And if you try PyPy and it doesn't make your program faster, well, it might be a problem in PyPy, but there might be a way to remove the bottleneck and to improve things. So please look at it. And also, there are other companies which I could mention, because what we saw is that not everyone who uses PyPy tells us. which is a good thing. At the beginning, years ago, we saw that the early adopters always came to the IRC channel and to tell us we are using PyPy and we see this problem and that problem and it's slow here and fast there. So we knew that free companies were using PyPy. But now, a lot of people apparently are downloading it and using it without telling us, which is very good because it's a good sign of maturity. It's not that if you download CPython, you write a mail to Guido van Rossum to tell him that you are using CPython. And so it happens that talking with people, I discover more and more usage in the real world. Today, I discovered that Bitbucket uses PyPy on their server for their backend things. So I hope I have answered the first question. Next, then let's try the second one. What does does package X work? So usually, if you have a package, there are two categories of packages. There are packages in pure Python and packages written in C, like a Z extension. If the package is written in pure Python, there is no problem. It has always worked because PyPy is very compatible with CPython, so it's very, very likely that your package will just work without doing anything. One of the areas in which PyPy has always suffered was the C extension one, because to write a C extension you have to use the C API of CPython, which we don't offer as a native API. We have a compatibility layer, which is called CPyExt, and we improved it a lot during the years, and it's getting better and better, and right now the focus is on the compatibility area. So we are working to make CPyExt more and more compatible, so that you can just install whatever package you want and have it working. It's still slow. It is slow when you cross the border between Python and C. It's slow for bad reasons, just because we never optimized the code. There are a lot of low-hanging fruits to be taken, which means that probably in the next months we will try to optimize it, and we should get very good speed ups. At least this is what we expect. There are already a couple of branches started to fix some of these problems. But I would like to underline that this is still a compatibility layer. If you want to write a new code to interface C libraries, probably you should use the more native way, which is CFFI. CFFI is a library to write bindings for C libraries, which works very well both on CPython and PyPy. So if you start from scratch, you should just use CFFI. If you have an existing package, then you go through the compatibility layer and be happy with it. I want to show a quick demo because, can you hear me? And now, okay. Yes, but how can I do the demo if I can sit down? Let's try to do it. Maybe it's easier to just do this. So what I did a couple of days ago when I was preparing this talk, it was to try to do the user experience. Like, let's see what happens if I download PyPy from the internet as a normal user. And then I tried to install random packages and see if they worked. So at first I tried Jupyter, which is very used in the scientific area as an interactive notebook. So this is a Jupyter running on PyPy. It just worked. I pip installed it and it worked. So let's try start one. We try to run commands. Yes, as you see, this is Jupyter running on PyPy. It works good. But usually, when you use Jupyter, it's because you want the scientific packages. And this has always been a big problem of PyPy, because in the past we used to say that NumPy doesn't work, SciPy doesn't work, Pandas doesn't work, and etc. And now what I did was, well, let's try pip install NumPy, well, it worked. Pip install SciPy, well, it worked. Pip install Pandas, it worked. So I want to show you that I'm not, well, I'm telling the truth. These are examples that I looked on the internet. I don't even know what they do because I'm not like a scientific developer. This is trying to plot something using Pandas, NumPy, and matplotlib. And yes, it just works. This is the example I looked on the internet. Thank you. This is another example for SciPy, and yes, it works again. Good. So this really makes a difference because until a couple of years ago, a couple of months ago probably, if you wanted to try PyPy, you could not because your program depended on this library. And now it means that suddenly you can. Of course, this is not the whole story. I'll say I would have finished to do my work and I could go to Bahamas instead of developing PyPy. So things works, but there is a but. So for the NumPy, I think the support is very good. The guy who is doing the testing on NumPy on top of PyPy told me that all NumPy tests basically pass. There are like 5 failing tests or something, which means that it's good. The biggest problem for NumPy right now is that our garbage collector doesn't know much about the NumPy stuff, which means that if you create a lot of NumPy arrays, which allocates a big chunks of memory, the garbage collector doesn't know about memory. The memory will be freed eventually when the garbage collector runs, but the garbage collector doesn't know how often to run because it thinks that the memory actually consumed is much less than what is in real. So to you, it looks like a memory leak because you are creating a lot of objects and the garbage collector never frees them. There is already a patch, which is probably somewhere in some pull request trying to go to the NumPy upstream repository, in which you can, in which NumPy can tells PyPy how big is this object actually, so that the garbage collector can do a better job. So if you experience something like this, something which looks like a memory leak using NumPy, most probably this is the problem. And hopefully this will be solved in a couple of releases, maybe next NumPy releases or next PyPy releases or both. What about the other libs? Well, Python works. A lot of the libraries I'm talking about are depending on Python because they are written partly in Python. So Python works. You can write your library in Python and be happy. For Pandas, we have a lot of passing tests. We still have a big, in absolute term, amount of failures, like 600 failures. But of these 600 failures, 500 are because we don't support Tkinter, the GUI interface. So if you don't care about this stuff, the actual failures are much less. But still, we are working on fixing them. And when I say fixing them, it doesn't mean that PyPy is wrong, or maybe it means, but it really depends. Sometimes the problem relies on the library, because the library uses the C API in a way which is not supposed to be used, but on CPython it still works, by chance. So sometimes we need to fix PyPy, sometimes we need to fix Pandas or SciPy or whatever. So we are doing this kind of job to improve both sides continuously to make sure that that things are progressing. There are still a couple of segfaults in Pandas, they told me. If you run the test suite, sometimes it's segfaults, and we are trying to understand if it's a problem of Pandas or of PyPy, or, well, hopefully we will fix it soon. For SciPy, the situation seems to be better, but if you run a PyPy test, you consume a lot of memory, like 4 gigabytes of memory. And most probably this is caused by the apparent memory leak that I talked about earlier of NumPy. So when we solve it, hopefully we will see a better shape of memory consumption in a SciPy test. And for Matplotlib, yes, it mostly works, but again, we don't have any GUI interactive backend because we don't have a NetDistinctor, we don't have a Qt, and etc. But if you use Matplotlib to produce PNG files or to show things in Jupyter, it works. Before talking about Python 3, I would like to add again the disclaimer that yes, these libraries now work, which means that you can start trying using PyPy on your programs, but CPyX is still slow. So depending on the workload, you might see a total slowdown of your program. Because if your program spends a lot of time in C and a lot of time in Python, well, probably the C part is not affected, the Python part is sped up, so you see a total gain. But if you have a lot of going back and forth between C and Python, like you have a loop and you call a NumPy function again and again, then this is probably a bottleneck which kills your performance. Because every time you cross the border, you spend a lot of time. This is something that I hope to fix in the near future, but right now you should be prepared for it. So, third of the questions, what about Python 3? Usually in the past, we used to say that yes, we will eventually implement Python 3. We are slowly working on it, but it was not a priority. Now it is. Things changed thanks to Mozilla, which gave a big grant in money to the PyPy team to work specifically on Py 3.5 support. And as a result, there are 3 or 4 people working half to full time on this, and the development of Py 3K sped up dramatically. The net result is that the latest PyPy release includes also a Python 3.5 release, which we say it's like a beta quality because not all of tests pass, but a lot of people are already using it, they are reporting that well, the program just works, so they are happy about it. And in particular, there are early results about async I/O benchmarks, which async I/O seems to be one of the cool new features of Python 3. And on PyPy, you see very good speedups, up to 8 times faster. In the graphs, they are measuring requests per second, so the bigger the better, and PyPy is the red one, of course. So, I think I have answered all the questions now. As a bonus topic, I would also want to briefly talk about VMProf, which is a new project, like a spin-off of PyPy, which we developed recently. It's a statistical profiler. The idea is that you can use it to spot the bottlenecks and the slow path in your code. It's very low overhead, so you can use it in production if you need, and so you can measure things with a real workload, not a dummy benchmark. And the other key feature is that it works very well both for CPython and PyPy, and VMProf is able to distinguish the various situations, so it can show you how much time you are spending in the interpreter, how much time you are spending in compiling the code using the JIT compiler, how much time you are spending in the compiled JIT code, or if you are using CPython, how much time you are spending in an external C library. If you want to run VMProf, well, this is the syntax, but if you just Google for it, you find the documentation. I just want to show you briefly how it looks like. So, for example, this is I just downloaded from the internet like a Project Euler solution for some problem which I don't know about, and this solution used NumPy. So I ran it through vmprof, and you see that the red stuff are pure Python function, and the blue stuff are the native function. So in this particular case, this benchmark spends a lot of time running code inside NumPy written in C, which usually it's what you want, but it depends on the workload, of course. And this is a flame graph. It shows you should look at the leaves and see where they are, where you spend the time. In this particular case, I didn't have the debug symbol of NumPy installed, so it doesn't tell me the name of the function, but still. And the same program run on PyPy gives this flame in which you see for each function it showed me the time spent in JITed code, which is green, and the time spent in the interpreted code, which is before the JIT kicks in, which is red. If you see a lot of red nodes, it means that probably your program didn't run enough to let the JIT warm up. And so yes, that's basically it is. I think we are almost out of time. 5 minutes, so there is time for some question if you have. There are questions.
Can I ask you if you have tried to communicate with CPython team and merge the effort of developing, maybe creating a CPython 4 with JIT inside to create a new unique project?
Well, of course, the CPython team knows about PyPy, and PyPy has been around for years now. But there is nothing like merging because it's a completely different project. PyPy means Python in Python. It is written in Python, it's not written in C. So it's a completely different project that doesn't make sense to merge them. At some point, it might be that PyPy becomes the reference implementation for the Python language. Or maybe it will be recognized in a more official way. It means that if you go to python.org, you can choose which version of Python to download. But, well, I don't think this is the biggest problem now. We need to fix some problem of PyPy so that you can actually use it as the default implementation, because right now there are still problems like the one I described, which prevents everyone to use it.
Okay, thank you.
Welcome.
Thank you very much for all those good news. The question is, how are you going to work around the context switch latency between PyPy code and C code?
Well, there is no, you talk about context switch, but I think it's the wrong wording, because there is no context switch. It's just, at the end, PyPy...
Same process.
Yes, PyPy at the end is something which is compiled in C. We start with a Python program, and then at the end we produce C code, which is compiled by GCC, and then this is what you run. And so we are a C program calling another C function. In theory, should not be hard. What is slow right now is that the CPython C API expects the objects to have a certain semantics. In particular, they expect the objects to have a reference counting. And, but PyPy uses a non-reference counted garbage collection mechanism, which means that basically for each object we maintain two
data
structure, one for the PyPy word and the other for the CPython word, or the C word, let's say. And every time we cross the border, we need to do a mapping between the two. And this is one of the reasons why it's slow. But we already managed to speed up one direction of the lookups by adding a field which is specially handled by the GC, so that the GC knows that this particular field keeps also the CPython object alive, and etc. On the other direction is right now is done by using a dictionary lookup. You maintain a big dictionary of
you have
addresses.
an index, external index for C object.
Yes, exactly. And there are options. One option is to add a field to every object so that there is a bidirectional lookup, but this will make all the objects larger, so maybe it's not a good idea if you don't need the C extension. So it's trade-off. We need to think about it. Welcome.
Thanks for the great PyPy overview, and I would like to ask you actually two questions. One is that you mentioned that crossing the C-Python boundary usually involves a high cost, and you mentioned about using CFFI.
Yes.
How much is the footprint on that and the gain of using it? Also because it's actually convenient to write and all the other things. And the second question is, what is PyPy good at? So what kind of code style should prefer? Like it's good at optimizing loops or function calls or stack stuff, so something like that. I mean, few things which don't impact a lot the code I'm writing to, but targeting PyPy at some way which doesn't involve like using all the quirks and just structuring the program better.
Okay. I already forgot about the first question, which was the CFFI versus PyPy. Yes. I don't know the exact numbers. I think that if you have a tight loop calling just one empty C function, probably if calling it through CFFI is like 100 times faster than CPyExt. Because CFFI is extremely optimized for PyPy. The JIT knows a lot about it, so what happens is that if you have a C library wrapped through CFFI, when the JIT calls it, it inserts like a direct call in the assembler to the C function, removing all the overhead of FFI, indirect calls, and etc. So it's as fast as you can get. CPyExt has to go through the layer I was talking earlier, so it's much slower. The second question was if there is some particular Python code in which the JIT is very good at optimizing it, right? In general, the JIT is able to optimize all the abstraction overhead. So for example, if you have a number, suppose you have a loop which sums with the addition of some numbers, and you have integers, so this is very good. So suppose you take these integers and wrap them in some classes. So you have a point, and instead of keeping the two variables alone, you write your nice point class which has two fields. And then in the loop, you create new point objects every time you want to add them. And then the JIT is able to completely remove this overhead. And the generated assembler is the very same as if you never had the point Python class at all. So if you look at the assembler code, you see that the two variables are kept in registers of the CPU, and the new objects are never allocated. So this is the kind of stuff in which PyPy shines. And a lot of optimization that you usually do for CPython, they are completely useless for PyPy because the JIT is able to do it by yourself. Usually on CPython you have a loop with the method call, and you move the lookup of the method out of the loop so you don't have to do it again and again. Well, for PyPy it doesn't change anything because the JIT optimized it already. So
thank you.
Welcome. Do we have more time? Yes.
Hi, thank you for the update. It's really nice to see PyPy progressing that fast. I just wanted to ask you, what is the state of the software transactional memory project?
Good question. This was something which was, we had a lot of hopes on it a couple of years ago. The state is that it was a research project, and the basic research has been done, and it more or less works. But the lead developer, which is Armin, told me that in practice it's very hard to use it in real world, because what happens is that you have this multi-threaded program which tries to advance in parallel, and every time there is a conflict you have to roll back, so you spend a lot of time and things go slower, and so you have to painfully search for all the conflicts and things are slow until at some point you manage to not to have conflict, then it's suddenly fast. But apparently this is not something which is very viable as a development way, because then maybe you introduce something else and your code is 10 times slower again. So I think that this project is a bit in pause, let's say. I never tried it by myself, but people who tried it told me that they don't put a lot of hopes on it, but you never know, of course.
Okay, thank you.
Anyone else? Okay.
What's the compatibility with the standard CPython implementation regarding the inspection? What mean frames, callbacks, and things like that?
I'm very compatible.
Okay.
You can do all the tricks you want.
Okay.
You can sys.getFrame, go back. Maybe sometimes you break the JIT in the sense that the code, if you do too much dynamic inspection, maybe the JIT cannot work, so you go a bit slower. But there are a lot of libraries around who do a lot of weird, dirty tricks, and they work on PyPy. So I would say that this just
because
works.
by nature it looks like template engines are a really good case for PyPy, but
Yes.
they always mess with deckings for error reporting and what else.
I think that Django works and the other template engines work, so maybe one good project will be take the Django template engine, try to run it on PyPy and see if it does anything stupid to break the JIT optimization. So maybe it works, but it's slow or not as fast as it could be. But as far as the compatibility goes, I would bet my things on the fact that it just works. Okay, thank you.